Hello everyone, my name is Lymphocyte. Within the white blood cell family army, I belong to the specialized agranulocyte division because my cytoplasm is smooth and clear, lacking the coarse chemical storage granules seen in my siblings. If you look at a standard laboratory report, I am the second most abundant white blood cell type, making up 20% to 25% of your total leukocyte count. While frontline troops like Ned the Neutrophil handle general, immediate threats, innate immunity, my branch specializes in adaptive, specific immunity. I am the intelligence agency, the elite special operations force, and the long-term memory bank of your immune system. I don't just mindlessly attack. I identify the exact molecular signature of an invading pathogen, coordinate a highly targeted strike to destroy it, and then memorize its face, so your patient never gets sick from that exact same germ again. The Special Ops Unit's three types of lymphocytes. To protect the body with precision, our lymphocyte division is split into three distinct, highly specialized tactical branches: T cells, B cells, and natural killer NK cells. 1. T lymphocytes, T cells, the frontline commando force. We are manufactured in the bone marrow but migrate to the thymus gland, right behind your breastbone, to mature and graduate from sniper school, which is why we are called T cells. We handle cell-mediated immunity, meaning we fight the enemy face to face. We are split into two main tactical squads: helper T cells, CD4 and R plus cells. The military generals. We do not directly kill invaders. Instead, we inspect the trophies brought to us by antigen-presenting cells like Max the macrophage. Once we confirm a threat, we secrete chemical alarms called cytokines to activate, deploy, and direct the rest of the immune army. Critical nursing link: the human immunodeficiency virus, HIV, specifically targets and destroys us, CD4 P+ cells. Without our generalship, the immune system becomes completely paralyzed, leading to AIDS. Cytotoxic T cells, CD8 cells, the assassins. We receive orders from the helper T cells. We patrol the body looking for cells that have been hijacked by viruses or have mutated into cancer. When we find one, we latch onto it and inject lethal proteins that force the infected cell to self-destruct. 2. B lymphocytes, B cells, the smart weapons factory. We stay behind and mature right inside the bone marrow, which is why we are called B cells. We are responsible for humoral antibody-mediated immunity. Instead of traveling to the battlefield to fight hand-to-hand, we sit safely in the lymph nodes and manufacture smart missiles called antibodies, immunoglobulins. When a specific antigen floats by, our B cell activates and clones itself into a massive plasma cell factory. We pump out thousands of tailored antibodies per second into the plasma. These antibodies travel through the blood, lock perfectly onto the invading bacteria or virus, clump them together, and mark them with a giant target so the macrophages can easily swallow them. Memory B cells. After the war is won, a few of us turn into long-lived memory cells. We float around for decades. If that exact same virus enters the body years later, we recognize it instantly and launch a massive antibody strike before the patient ever shows a single symptom. This is the exact mechanism behind how vaccines protect your patients. 3. Natural killer, NK cells, the security patrol. We are the unique wildcards of the family. Even though we are structurally lymphocytes, we act as part of the rapid, non-specific innate immunity defense force. We patrol the bloodstream and tissues looking for any host cell that seems abnormal, lacks the proper cellular ID card, MHC class Y molecule, or shows signs of viral infection or malignant tumor growth. We destroy these suspicious cells on site without needing any prior activation or specific antibody targeting. Common clinical conditions and imbalances. When our lymphocyte force drops too low or turns against the body, it leads to distinct clinical pathologies. 1. Lymphocytopenia, low lymphocyte count. A dangerous shortage of lymphocytes typically caused by immunodeficiency diseases like HIV, AIDS, severe malnutrition, chronic stress, or immunosuppressive therapies like chemotherapy or systemic corticosteroids like prednisone. A lymphopenic patient has lost their smart defense force and is at an extreme risk for picking up dangerous, rare opportunistic infections. 2. Lymphocytosis, elevated lymphocyte count. an abnormal spike in lymphocytes. While neutrophils spike during bacterial infections, lymphocytes typically skyrocket in response to acute viral infections, such as infectious mononucleosis, chickenpox, mumps, or hepatitis. The chronic exception? A massive, uncontrolled overproduction of abnormal cancerous lymphocytes inside the bone marrow is known as chronic lymphocytic leukemia, CLL. Critical nursing labs and clinical applications. The WBC differential evaluation on a standard complete blood count CBC with differential, the normal reference range for lymphocytes is 20% to 40% of the total white blood cell count. The diagnostic clue: as a student nurse, if you are looking at a patient's labs and see an elevated total WBC count, you will look directly at the differential to determine the cause. High neutrophils, plus left shift. Think bacterial infection, e.g., pneumonia, appendicitis. High lymphocytes, think viral infection, e.g., influenza, mononucleosis. Monitoring CD4 counts. When caring for a patient with HIV, checking their absolute CD4 T cell count is your highest priority neurological immunological assessment. A normal CD4 count is 500 to 1,500 cells, M3. If that number drops below 200 cells, MM3, the patient is officially diagnosed with AIDS and must be placed on strict prophylactic therapies to prevent fatal fungal or viral infections. Remember to like, share, and follow this account. If you have a question or a topic you would like next, let us know in the comments section.